Ladies and gentlemen, I don't mean to alarm you, but we have a double agent in our midst. He is hidden in plain sight, regulating genetic expression by day and serving as a viral accomplice by night. He is present in each and every one of your cells right now, waiting patiently for a signal from his virus boss to turn against you. His name is the protein WDR5, and our mission is to elucidate his role in viral infections like Zika, Ebola, HIV, and measles, and use that information to protect millions of lives around the world. Now, anyone who's ever read a spy novel knows that knowledge is power. So in order to better understand the role of WDR5 and other traitorous proteins in viral infection, we need to have a solid understanding of viral infection. Imagine that your DNA is like an instruction manual, and your cells factories full of powerful, sophisticated machinery capable of creating everything described in that manual. Normal cells have their own set of instructions, and use those instructions to create everything the cells and your body needs. Sneaky viruses tamper with, tweak, and add their own instructions, tricking the cell into becoming its slave, hijacking the machinery, and making everything the virus needs in order to reproduce and infect again. Once the cell is depleted of all its resources and the virus is ready to infect, the cell's ripped apart and the virus is free. WDR5 works here in these cellular factories, but what is it doing there? Who else is involved? And how can we use that information to take down these viral villains? I believe that the cure to an effective treatment to devastating viruses like Zika and Ebola lies buried deep in the infectious mechanism of measles virus. The infectious mechanism of measles virus is very similar to that of Zika and Ebola, so by better understanding the role of these viral accomplices in measles, we can better understand the role of these proteins in these other two viruses. My research tackles this question by using microscopy and subcellular fractionation, which is biologist for separating a cell into its individual components in order to gather information about the localization of WDR5 under different infectious conditions, and further uses immunoprecipitation, which is biologist for isolating a protein without breaking its interactions to another protein to gather information about additional viral accomplices. With this information, we get that much closer to a cure and ending this arms race between virus and vaccine. And with this information, we can hope to turn deaths due to viral disease from a statistic to an infrequent tragedy. Thank you.